So this is what the actual formula for acceleration looks like. Notice acceleration, notice the units that it marks there, meters per second squared. Those are our SI units, what we should be using, and it's built off of the SI units for velocity and the SI units for time. So for velocity, meters per second, for time, second. So acceleration ends up being meters per second, or meters per second squared. Okay? Now then, acceleration is equal to my final velocity minus my starting velocity divided by my total time. Here's where you need to start remembering some things. For instance, each of these velocities is a vector. Since this is made of vectors, that acceleration is a vector, meaning it has a direction too. Luckily, most of the time, all we do is a positive or negative, because that can indicate whether it's going to the right, up for positive, or to the left or down for negative. But then we could also write things like north, south, east, west. All of it is just to indicate that these are vectors and they do have a direction. Also notice that this is more parts to this formula than the velocity formula is, meaning to algebraically solve these, we can't really just do a fun triangle like we did before. That doesn't really work with acceleration. So think about acceleration, there's no triangle, okay? We're going to have to do a little bit of algebra. So let's take this equation, that acceleration is equal to, I'm going to remember that it's a vector, the final velocity, I'm just going to indicate a little subscript f to notice that, minus my start velocity or initial velocity. So I'm going to do that. Both of those are vectors, divided by my change in time. Okay, I'm going to take this formula and hopefully I can break it down into other useful parts so that I can solve it algebraically for the other ones. So let's go ahead and we'll use black again for the overall, but we're going to start with acceleration is equal to final velocity minus starting velocity divided by time. And let's solve it first for final velocity. To do that, we need to first get rid of this time on this side, because we're going to be solving it for final velocity. So time is multiplied before these are subtracted, so I need to, or divided before these are subtracted, so I need to get rid of it. Meaning, I'm going to multiply both sides by time. And that'll cancel out time on there, and now I can rewrite this as acceleration times time is equal to velocity final minus velocity start. All right, now I need to get rid of this final, or this start velocity, and it's being subtracted or is a negative value, so I'm going to add it. So if I add velocity start to this side and I add it to that side, it'll cancel out over here, and I can rewrite that I now have acceleration times time plus velocity start is equal to my final velocity. But I probably want to rewrite that so that I switch sides. Remember, you can switch sides and there's no real trouble. So let's go ahead and switch sides and rewrite it all as that my final velocity is now equal to acceleration times time plus my starting velocity. And I now have a brand new equation, right? However, we had to algebraically solve it by doing all of this stuff. All right, so let's put that formula now up there with the other one, and let's see if we can solve it for yet another one. This time we're going to solve it for velocity start, but I'm not going to use my original equation up here. I'm going to use the one I just derived because it's much simpler to solve it for velocity start. So let's rewrite it. Of velocity final is equal to acceleration times time plus velocity start. Now, again, I told you we're going to be trying to get that all alone on the equal signs. So that means we got to get rid of all of this. But that's actually pretty easy. All we have to do is subtract both of those together from both sides. So I'm now going to, on this side, say I subtract acceleration times time together there. But what I do on one side, because that would cancel those out, I have to do on the other side, meaning I have to subtract acceleration times time from that side too, which gives me a whole new equation, and I'm going to go ahead and rearrange it, of velocity start is equal to final velocity minus acceleration times time. This once again gives me a brand new equation for me to use, this time solve for velocity start. Again though, I had to do all of the algebra of moving things around to get it there. Okay? So now hopefully we have, and we can put it yet again right up there. Okay? So now there's only one last variable to solve for it to get enough equations to be able to do all of these. And that one is going to use that original formula again. Acceleration is equal to final velocity minus start velocity divided by time. And this time we're going to be solving for time. So notice it's divided over here, so we're going to move it to the other side by multiplying, the same as we did the first go round. So multiply by time, cancel it out over there. What we do to one side, we have to do to the other. Multiply by time there. And that's going to give us a brand new equation of acceleration times time is equal to final velocity minus start velocity. But we need to get rid of the acceleration on this side. It's being multiplied. Opposite of multiplying is dividing. So that's what we'll do next. We'll now divide both sides by acceleration. And that'll give us our final formula that we need, that time is equal to final velocity minus start velocity divided by the acceleration. But remember, we had to do all of the algebra first in order to get to the new equation. And this gives us our final equation that we really need. So now we should have 4 different formulas from our one formula. We have our original acceleration formula. Then we have this formula solve for final velocity. Then we have it for starting velocity. And then we have it for time. Now you can solve it any which way, and I've already done all the algebra for you, and it's set up so that you can just use these formulas. So if you need, you can use these now, but it would help if you could do what I did and break that one down into the ways that you need to use it yourself.